Okay, today we're multiplying and dividing radicals. It's a really simple it's really simple to do. Let's not make it complicated. So written right here are your steps to multiplying. All right, first thing first, we're going to multiply the coefficients. We're going to multiply the radicands or the radicals. And then we're going to simplify. So if you see down here, radical A times radical B is the same as if you just multiplied A and B together and put them under a radical. All right, so these steps are going to show up over and over. All right, so let's look at this problem and see if we can follow our steps. First of all, step 1, multiply coefficients. Okay, so my coefficients are 3 and 2. I'll multiply those together. Multiply the radicals together. 4 times 3 is 12. X squared times x cubed. All right, add exponents on variables, so that would get me x to the 5th. Now I'm going to simplify the radicand, or what's under the radical sign. So the 6 stays out in front here. I'm going to take this 12 and I'm going to break it down into x. Oops, sorry, not x. I was getting ahead of myself there. I'm going to break it down into 4 times 3. Now the x to the 5th, I want to pick out the biggest perfect square in x to the 5th, and that would be x to the 4th, and that would leave x left over. Okay, so now I'm going to go through. This 6 comes down. The square root of 4 is 2. I can't take the square root of 3, so that stays in a radical. I can take the square root of x to the 4th, that's x squared. And I can't take the square root of x, so it stays in its radical. Cleaning this all up, I get 12x squared radical 3x. That's my answer. Okay, another one. Let's see here. Multiply the coefficients. Negative 8 times 3 is negative 24. Multiply the radicals. 5 times 10 is 50. X to the 5th times x to the 4th. I add the exponents together, get x to the 9th. Now we're going to simplify. The negative 24 stays on the outside. I'm going to take the 50, I'm going to break it down into 25 and 2, because 25 is the biggest perfect square that goes into 50. And x to the 9th, let's see, the biggest perfect square that goes in x to the 9th is x to the 8th, and an x left over. All right, breaking it down, negative 24, the square root of 25 is 5. I can't take the square root of 2, so it stays. The square root of x to the 8th is x to the 4th. And I can't take the square root of x, so it stays in its radical. And we get a nice little, let's see, negative 24 times 5 is negative 120. X to the 4th, square root of 2x. Hey, this isn't that bad. All right, can you do one without the little steps in front of you? Let's see if I can remember them. Step 1, multiply the coefficients. 8. Step 2, multiply the radicands together. 2 times 6 is 12. M squared times m to the 9th. I add the exponents together. X squared times x to the 4th. I add the exponents together and get 6. 12, I'm going to break down into 4 times 3, because I'm going to look for perfect squares. M to the 11th, I'm going to take out m to the 10th and m, and x to the 6th. no need to break x to the 6th down because it's a perfect square in and of itself. So there's no need to look for a big perfect square that goes into x to the 6th. All right, now we're just down to clearing up. 8 comes down. The square root of 4 is 2. The square root of 3 can't be done, so it gets to stay in its radical. The square root of m to the 10th is m to the 5th. I can't take the square root of m. I can take the square root of x to the 6th, it's x to the 3rd, and there is my final answer. All right, so we have just a little different here. We have multiplication going on because we can see it right here. But we have a monomial being multiplied by a binomial. So we're going to have to distribute. So we're still going to follow our steps. This is the square root of 8 times 6 plus the square root of 8 times the square root of 2. It's a little different because we don't have a lot of coefficients and we don't have a lot of variables. So we're still going to follow our steps. Multiply the coefficients together. Well, the coefficient here is really 1. So this becomes 6 radical 8. The coefficients right here are 1, so 1 times 1 is 1. And now I multiply the radicands together and I get the square root of 16. Following my laws, I'm going to break down. 6 doesn't get broken down. 8 gets broken down into radical 4 times radical 2. And look at the beauty here. The square root of 16 is 4. Now when I go to clear up, 6, square root of 4 is 2. Can't take the square root of 2, plus 4. 12 radical 2 plus 4. Now the question is, we cannot add these together. This is my final answer. You cannot add this together and get 16 square roots of 2. No. I only have 12 square roots of 2 and 4. This is not 4 square roots of 2. If I had this, then yes, indeed, I can add them together. We learned that a couple days ago. But that's my final answer. Okay, one more and we're done. Oh, so this is a binomial times a binomial. And the beauty of math is once you create a law, it has to be followed throughout math. So when you did this back in algebra, you use that terrible F word FOIL, and I'm just going to do my double distribution. 1 times 3 is 3. 1 times negative radical 5 is negative radical 5. Okay, now I have to distribute on the bottom here. That becomes 3 radical 5. And radical 5 times radical 5 is minus radical 25. Put everything all together. This 3. There are no more integers to add it with, so it stays by itself. Negative radical 5 plus 3 radical 5 gives me plus 2 radical 5. Minus the square root of 25. Uh-oh. The square root of 25 is 5. So now I'm not done because now look who can go together. Now there is an integer that the 3 can be added to. 3 minus 5 is negative 2 plus 2 radical 5. That is my answer. They cannot get added together because one is irrational and one is rational, and they cannot be added together. Okay, we're done. Nice short lesson today.